Hi everyone, welcome back to our Linux Beginner to Pro series. We are on the topic disk management. In this topic, we'll be learning what are the implementations of disk management, what are the types of disk management, or how do we create the partitions and volumes into the disk management, and also we'll be understanding the requirements and how you will be getting the request to create the partitions and how will you do it. Before we start, disk management is basically a requirement where you have to create multiple partitions in order to store the different type of data such as application data or website data or database data. So for these purposes, you have to create different partitions or volumes. Also, for keeping the root file system or the operating system files inside the system, you need root file system and boot and swap. There are a lot of volume types or partition types which you need in the system so that you can keep the data category wise. The benefits of disk management is if you create multiple partitions, your data is safe compared to kept into a single directory or a single partition, because if you are keeping it into different partitions and different volumes, even if your one volume gets corrupted, your data is safe into different volumes. And it is very easy to manage the permissions of the particular data, because if you are keeping it into the separate file systems, you can easily manage the permissions and authorization of different users who can access the data, who can read it, who can write it, or who can execute the files and everything. So it's very important to understand the disk management methods. Before we start, let us connect hard disk on our system. So in this Oracle VirtualBox, if you click on the settings of the particular virtual machine, go to storage, and here on the controller SATA, the second option says add hard disk. If you create here, I'm giving the size of 10 GB just to show you for example. Click on finish, and the one which is showing as not attached, here it is highlighted. Now click on choose. So VM app 1 VDI, this disk has been attached. Remember that your system must be in powered off state before you add it. However, into the real environments in your VMware or Azure or AWS cloud platforms, you don't need to power off your system in order to add a new hard disk. But here on the VirtualBox Manager, you need to keep your virtual machine in powered off state so that you can attach a new disk here. Now I'll be starting the virtual machine. So my system has started and I have taken the putty session with the root user. Always remember that you should be doing disk management either with the sudo privileges or with the root user itself. So the first command which we will execute in order to see what all the disks are attached to our system is lsblk. Lsblk lists all the block devices. What are the block devices? In which device there are blocks and sectors, all those devices are known as block devices, such as hard disk drive or compact disk, which is in short known as CD-ROM. So all these devices are listed into the command output of lsblk. Now we have our HDB, which I just connected before the system powered on, that is of 10 GB. Now I'll be showing you how do we create the partition. Before that, what kind of request we'll be getting? Say that, for example, this is a app server where the application team wants a separate storage of slash app, and they need at least 5 GB of space to keep their application related data. This is just an example. They'll be not needing 5 GB or 10 GB. They may request for 50 GB, 100 GB, 1 TB or such kind of spaces, but we'll be taking the example with 5 GB. What is a file system in Linux? File system, as the name itself suggests, that a system where we keep the files. in some order or randomly we can keep it, but the system tracks where the file has been kept, the location of the file, and next time when you try to read it, it will be taking you to the same location and you will be able to read the file. So file system consists of two things here. One is partition or volume and another one is the directory. In Linux, you need to create a partition or volume first, then format it and then mount it on a directory in order to get inside the directory and keep your data, read it or write it. So you must understand this before you start understanding what is a file system and how do we create it. In short, we can say the partition and directories combination is basically the file system. Okay. Now there are two types of or there are two methods to create the partitions or volumes in Linux. One is standard partition, where we can create the partition out of one disk, and the partition size can be maximum to the actual size of the disk. And once the partition is created, it cannot be extended further. So your file system size also will be fixed. Once you have created your file system with a standard partition, the size will remain same till the end of its life. If you want more space, you may need to create a bigger file system and then move all the data from the previous file system to the new file system. That is the only way to extend the space or get the more space on the standard file systems. But if we talk about LVMs, LVMs are flexible, and those file systems can be extended later if required. We'll be talking about it into the next part. Today, let's understand about the standard partitioning. So fdisk is the command to create the standard partition. You have to give the path of the disk. Always remember all the disks are inside the slash dev. So you are seeing SDB here, but I am giving the path called slash dev slash SDB because your SDB resides inside the slash dev. Fdisk slash dev slash SDB, press enter. Here, if you are confused, you can press M to get the help. I'll be highlighting most important options which you need into daily life or day-to-day practice of creating the partitions. The first is D to delete a partition, N to add a new partition, and once you are done with creating the partition, you can either write the table to disk and exit or quit without saving changes. So if you want to save it, you have to press W, and if you don't want to save the changes, you have to press Q. Let's press N to create a new partition, and as we know, we need 5 GB of space. So we'll be creating a 5 GB partition here. There are two types of partitions into the standard partitioning. One is primary partition and another one is extended partition. On one disk, maximum 4 primary partitions can be created, and if you want more than 4, it will be created as extended partition. So if you do not give any option such as P or E, it will take default P. So if you press enter, it will take primary partition. Now partition number 1 to 4. So you can create maximum 4 partition. It is saying about the sequence of the partition. It's not that if you give 2 here, it will create 2 partitions. It will create partition number 2. That's the sequence of the particular partition. So you'll go from the 1. The first sector should be left empty. Let the system decide where the first sector will start. And the last sector, if you are well aware about these calculations, you can give the sector number, or it's easier to give the size plus 5G. If you press enter, it will create a 5 GB partition. And now we want to save it. We'll be pressing W and enter. Now if you do LSBLK once again, you can see the new partition of 5 GB created here. You have the partition, but this cannot be used just like that. You will have to format it first. There are multiple types of file systems in Linux, out of which two famous file systems are ext4 and xfs. ext4 was the default file system type till RHCL7. RHCL7 onwards, xfs is the default file system type. When I say default file system type, it is not that if you create a partition, you don't need to format it manually. Here, inside the operating system you will have to format it for whatever file system you want, but during the installation, if you take root file system or boot file system, uh, the default file system type will be showing as XFS into the installation window, but here you will have to choose it. So there is a slight difference between ext4 and XFS file system type. uh, ext4 file systems cannot exceed more than 16 TB of partition size, whereas XFS can be created for 10 to the power 12 GB. And ext4, as I told you, it's a older file system type, where the XFS is newer file system type. And the third difference is that ext4 file systems can be extended as well as can be reduced, but XFS file systems cannot be reduced. Now you must be wondering that ext4 is the older file system type and still it is having extension as well as reduction feature, while XFS lost one feature. What is the reason? If you are well aware about the partition and disk spaces, if you have created a, let's say, 15 GB partition and you have used 8 to 9 GB of space and you want to reduce the file system by 5 GB, however you will be left with 1 GB extra space, but still if you reduce it there might be chances of data loss and the file system corruption. That is the reason in XFS they removed the reduction feature. If you want to format a partition, you have to run the command mkfs.ext4, or if you want to format it with XFS, write mkfs.xfs and then give the path of the partition, not the disk, /dev/hdb1. Now this disk has been formatted. The next step is to mount it. So you have to create a mount point. I'm creating mkdir/app. It's just a normal directory until there is a partition mounted on it. Once a partition mounted, it becomes the file system. So what is the difference between a directory and file system? When you have this directory /app, it is created under the slash. Now it will be consuming the space. If you are saving any file inside the /app, it will be consuming the space of root file system. But if you mount a partition on top of it, now the app directory will be consuming the space of that new partition. For this example, /dev/hdb1. Now the next step is to mount it /dev/hdb1 on /app. Now df is the command which will be listing out all the file systems available on your system. And if you want to see the sizes of those file systems, if you just run the df, it will give you a random number which you cannot understand what is the size of the particular file system. But if you run df-h, ignore the above file systems. This is because I have the containers and pods running on my system. But the last partition that you need to focus upon is /dev/hdb1, which is of 5 GB. It has been mounted on the /app directory. Now /app has become a file system. And if you want to list the type of the file system, use capital T option. It is saying that it is a XFS type of file system. Whatever file system you create, you have to make an entry in /etc/fstab file. If you do not create the entry into the /etc/fstab file, next time when your system reboots, this file system will not be mounted because your system doesn't know that there is a file system called /app. You have to tell the system by adding the entries in a fstab file, so that next time when you reboot your system, the file system will be auto mounted. If you want, I can show you by restarting this system, and or you can practice yourself. Just don't make the entry in fstab and try restarting the server, and you will see that this /app will not appear into the df-h output. What you will have to do, vi/etc/fstab. You need this data, the partition path, the file system type, the mount point, and few other things that we'll be seeing into the fstab file. Go to the last by pressing Shift G and press O to create a new line here, and go to the insert mode. Now here /dev/sdb1, that is the partition path. Then where it is mounted, on the /app. On the third parameter, we'll be mentioning the file system type, that is XFS. Here this default shows the permissions. If you want, you can reconfigure this by adding the different permissions for this file system, or if you are using defaults, that means it is using same permission as of the directory permission. Space 0, then space 0. This 0 will ensure that there are the logging being done, and the second 0 will be making sure. However, if it is 1, then only it will do the fsck. If it is 0, it will not do the fsck. Fsck is nothing but checking the file system continuity during the boot. If you keep it 1, the boot will become slow because it will start checking the file system before the boot, and it will take a lot of time. So we keep it 0 and then we save it. If you want to verify your fstab entry whether you have done everything correctly, just do mount-va. If it says already mounted or ignored, then you are good with your entry, or if you are seeing any error, you need to fix it. So this is all about creating a volume. Now, since the /app file system has been created by root, if you do ll/, you can see the /app file system is owned by root and the group root. Group and others do not have any permission. Let's say there is a user called, I'm just checking what all the users are there on my system. Okay, let's say that SRE group, SRE user needs this file system. So you will do chown SRE colon SRE. SRE user and SRE group will be the owner of /app file system. Now if you switch to SRE user, they can go to /app, and if they want, they can create their own files. Now you can hand over this /app file system to the actual users. They can go and create their own files. They can read it. They can do whatever they want. Okay. Now we'll be talking about how to clean up a file system which is unused. There is no data. If there is a data, you need to take the backup before you delete the partitions or delete the mount points. But if there is no data, how do you reclaim this space? First of all, you will have to go into the reverse order. First, delete the fstab entry. Do remember this, else you will end up with the maintenance mode of the operating system. So first of all, go to the last line. You can either comment it or you can delete the line. I'll not need this, so it's better to delete this line. Escape colon wq bang. Okay, I guess I'm logged in with standard user. Let me exit from here. Go to the last line, press double D, delete it, escape colon wq bang. Now you have to unmount the file system. Umount is the command to unmount the file system. Okay. Before mounting, we did formatting, but if we cannot do unformat, now we'll be proceeding to delete the volume. Fdisk again /dev/sdb. Remember that with fdisk you'll be using the disk path, not the partition path. Now press D If you press D, since there is only one partition, it will automatically choose the partition 1. If there were more than one partition, then it will be giving you option to choose between the options, whatever disks are available or whatever partitions are available. You can choose which one you want to delete, but here it has already taken partition 1 because there was only one partition. Now press W to save it. Now if you press LSBLK, you can see SDB is back to 10 GB and there is no partition under it. In Logical Volume Manager, we have the feasibility to extend the file system and also to reduce the file system with some file system types. Logical Volume Manager is made up with three components primarily. One is physical volume, then volume group, and the logical volume. Physical volumes can be made with either a partition or you can use the whole disk also. In the standard partitioning, your standard partition can be created out of a disk, so its size will be maximum to the size of the disk. But in the logical volume manager, you can combine one or more physical volumes into the volume group, and then you can create larger size of logical volume even though if you don't have any of the physical volume of that size. For example, if you want to create a 24 GB of logical volume or file system, you can have a 10 GB of disk and you can have a 15 GB of disk, and you can combine both of them together. They make 25 GB of volume group. Now you can create 24 GB of logical volume out of it. There will be no problem. But in standard partitioning, this is not possible. You can create either 10 GB of partition or 15 GB of partition out of both the disks in this example. The name volume group doesn't come from the grouping of logical volumes, but it actually comes from the name of group of physical volumes. So agree that logical volume is created out of the volume group only, and there will be multiple logical volumes also created on the volume group, but the volume group name doesn't come from logical volume. It comes from the group of physical volumes, because you can have more than one physical volumes combined together in the volume group. Now let us see. In our system, first of all, we'll be running the command lsblk so that we can see what all the disks are there or what all the partitions are there on my system. I can see there is a disk called SDA and there is a SDB disk which we attached last time, and we also performed a cleanup. Now we have 10 GB of disk here. I will take both the examples. We'll create the physical volume out of a partition first, and I'll show you how can we create physical volume using the whole disk. The command will be same, only the path will change. First of all, let's create a partition. N for new, P for primary. Number 1, let the first sector be empty. The last sector will create 5 GB of partition. Right? Yes. It says partition number 1 contains XFS signature. This is because we created the partition last time. Now we have erased that previous signature and we'll be writing these changes so that we can have a new partition of 5 GB. If this partition doesn't appear automatically, even though you have created the partition, you have to run the command part probe. Since it has already appeared, we don't need to do that. However, even if you do this, there is no harm, but this is not required here. If your partitions are not visible, you can run this command. Now, the commands of logical volume starts here. pv create and give the path of the partition or disk. Here we are using partition first, so HDB1. Enter. For the physical volumes, the path of the partition is the name of physical volume. But when you create a volume group, you have to specify a name here. Let's say this is the app server and we want to create a app VG. We are giving the name to our volume group. Now, whatever disk you are using here, you can use more than one disk also. Since we have only one, we are using only one. If we have more than one disk, we can define all those disk path parallelly together. Press enter. The app VG has created. To check the physical volumes, you have to run the command pvs, that stands for pv show. These are the two physical volumes on my system. Don't get confused with the disk, partition and physical volumes. Physical volumes are the component of logical volume manager that is made separately, that is intentionally made. We cannot say that SDA1 is also a partition, why it is not listed in physical volume. Physical volume is a component that we created manually. SDA3 was created during the OS installation automatically, but it was created as a physical volume, so it is getting listed here. VGS will list all your volume groups. We have app VG, we have Ubuntu VG. This VG was also created during the installation, and this is the one which we have created for 5 GB. Now we can create a logical volume out of it. So the size of logical volume can be maximum less than 5 GB. Now to create the logical volume, run the command lv create. Here give the name to the logical volume using option -n. uh, I'm using app lv. You can use any name, it's not a code, it's just a random name. If you want to give your name, you want to give server name underscore lv or -lv, even this underscore lv is also not a code. It is just to recognize, or it's a standard way to do it. If you want to give your own name also, there is no problem, it will work properly. Now give capital L to define the size. Here you can use small l also. Small l is for blocks and sectors definition, and capital L is for MB/GB size definition. Now I want to create a 4 GB partition out of it, or if I use small l and use 100% free, if I use this command, whatever space is left on your app VG will be taken by this logical volume /dev /app VG. Remember that VG goes inside the /dev again. Now you are not creating your logical volume on top of HDB1 actually. You are creating it on the top of app VG, which resides inside the /dev again. Press enter and your logical volume is created. Similar command lvs to see all the logical volumes. Now app lv has been created equal to the size of your app VG. Now if you see the VGS, there will be zero space left in your app VG. From here, all the steps are quite similar to your standard partitioning. As you have the partition, now next you do the formatting with mkfs.ext4 or xfs, whatever file system type you want, and then you give the path of the partition there. Here the partition path will be /dev /vg name /lv name. Press enter. The disk has been formatted. Next is you create a mount point called /app. It may exist because we created last time. Now we'll be mounting it. Mount /dev /app vg app lv on the /app. And if you run df-h, you can see the 5 GB file system /app has been created. And similar to the standard partition, if you want to make a permanent mounting or persistent mounting, you can use vi/etc/fstab. Remember the path here, you can use this path, or you can also use /dev /appvg/applv, or you can also use blkid of /dev /appvg/applv. This UUID copy this whole thing, and this path can also be used. This is the ID of your partition. This is the mapper path of your partition, and /dev /appvg/applv is the partition path or volume path. Any of these three things can be used into the fstab entry. /etc/fstab, do vi on it. Go to the last line, it's already there. Press O to create a new line, then slash dev slash app underscore vg slash app underscore lv tab. Where is it mounted on? Slash app tab. What is the file system type? It's ext4 tab. The permissions, defaults, log dump and fsck. And to check whether we have done the correct entry, we can use mount-va. It says ignored or already mounted, so every entry is correct, there is no problem. Now if I restart my machine also, my partition will not be missing, it will get mounted automatically. Now if I want to extend my file system, let's say that application team says this 4.9 GB is almost used and we want to have 5 GB space extra. Now first of all, you will be checking whether you have the space left on your VG or not. You can see the V free is showing 0. Now you will have to extend your volume group. How will you extend it? By adding a new physical volume to it. And we do not have any physical volume that is unused. So we will be creating a new physical volume. Again, now we have two options. We can create a new partition into the SDB because we have still 5 GB left here. We can create a partition here, or to show you how do we use a whole disk, now I'll be shutting down my server and I'll attach a new disk on my virtual machine and then I will create the physical volume out of a disk. Shutting it down. Just a reminder that this is only in Oracle VirtualBox that we need to shut down our system in order to attach a new disk. Into the real-time environment, you don't have to power off your server. The disk attachment will be done live. Once the system is powered off, go to the settings, click on storage, click on the add hard disk, click on create, next. Here I'm taking 12 GB to create a new disk, and the one which is not attached, you have to choose that. You can see the third disk has been attached. Click on OK and power on your machine. Once the server is powered on, restart the session and switch to root. Now if I run the lsblk command, see the output, another disk of 12 GB has been attached. Now you don't have to create a partition, just run pvcreate /dev /hdc. This time the whole disk will be made as a physical volume. Always remember that the LVM which you want to extend can be extended only if there is a space in its own volume group. So you have to extend that volume group if there is no space left by creating another physical volume and extending your volume group using the new physical volume. VG extend app underscore VG, give the path of the physical volume. Now if you run VGS, you can see 12 GB has been added to the app VG. Now I can easily extend my logical volume app LV by 5 GB. How do you do that? LV extend -L. This time you don't have to give the name because you have already created the logical volume. Remember this, I have seen many people repeating the same mistake again and again, that they use -N while doing the extend. Plus 5G. This time I'm showing you the use of capital L. Last time we saw how do we use small l with 100% free. I'm defining the size here, and this time you have to give the path of logical volume. Press enter. If you see lsblk output, now your app LV shows as 10 GB. However, if you run df-h, the file system /app is still showing 5 GB. The reason behind that is we did not resize the file system, we just extended the volume. To resize the file system, we have two commands. If the file system is ext4, we have to use resize to fs, and if the file system type is xfs, we have to run the command xfs underscore grow fs. So our file system is of ext4 type, so we'll run command resize to numerical to fs slash dev slash appvg applv. If it was xfs file system, just to show the command, don't get confused. If it was an xfs file system, then we would be using this command xfs underscore grow fs. But this is a ext4 file system, so we'll be using resize to fs. Now if you see df-h output, the slash app shows 9.8 GB now. This is how we can extend our logical volume. I'm not showing you how do you reduce it, but if you want, you can run lv reduce -l slash dev slash appvg slash applv. This is the command to reduce the file system, and this command can be executed only in the ext4 file system types. XFS file systems cannot be reduced, it can be only extended. Nowadays, file reduction is not in practice. We do not reduce any type of file system, be it ext4 or XFS. Even though we have the feasibility in ext4, but we do not use it because there is the chance of file system corruption, and also you need to unmount the file system to do the reduction. This is the command. You can have it for information, but I'm not going to execute it. So we have understood that we can create the physical volume out of a partition or out of a disk, and then we can combine multiple physical volumes in a volume group, and then we can create the logical volume out of the volume group. And after creating the logical volume, the same steps are performed, such as formatting the partition, then mounting it on a new mount point, and also if you want, you can give the permissions or the ownership to the directory for the particular user. Next is how do we clean up this. So first things first, remove the entry from fstab. Go to the last line by pressing shift G and press double D to delete this line. You can also comment it if you are going to use that file system later or mount that file system later. Do not delete the entry but comment it. Since I am going to clean it up completely, I am not commenting it out. Press W Q bang, save the entries. Now unmount the slash app, and now we will be deleting the LV. LV remove slash dev slash appvg app lv. It is asking for the confirmation, say yes. Now vg remove slash dev slash appvg. You can also use appvg, it will understand. Now pv remove, we used two new pvs, that is slash dev slash hdb1 and slash dev slash hdc. Both are wiped. Now if you run lsblk, SDC is completely free. However, the partition which we created is still there. So if you want to clean that also, use fdisk slash dev slash sdb. Now press D to delete the partition, press W to save it. Run lsblk again. The whole tree is clean. Now these two disks can be detached from the system and your volume will be reclaimed. Hope you have understood what is logical volume and what is the use of it, how it is better than standard partitioning, how do you create and how do you extend the logical volumes, what all the components are there and how can they extend or how can they reduce, and all the commands which can be used to manage the logical volume manager. If you have any questions or if I have missed anything you think, please comment down, and if you liked today's class, please like this video and subscribe our channel for more. We will be completing the Linux classes soon, and then later on we'll be starting the cloud classes. So stay tuned with us. Thank you so much.